Mitesh talking. Mitesh is a former student of the JK. He submitted his PhD about 3 months ago, and he just told me that he's got the corrections back, so he should graduate in the next few months or weeks. And he started a job with JK Tech in Sumner Park. Okay, so now he's going to talk about a bit of his PhD work and the work he's done after the PhD. Let me welcome Mitesh.
Thanks, Bill, for that. Yeah, no, so I would consider myself still a student because I haven't yet officially graduated, but I think fortunately I'm on course with that. It's been a while, so it's been calling. Anyway, thank you very much for coming to the talk. First of all, I would like to, I suppose, acknowledge a few people who have contributed towards some of this work. Tim Napier-Munn, who couldn't make it, and Dr. Luke Keeney, who also couldn't make it. So what I'm going to talk about is the application of a mineral flotation recovery test for ore characterization in geometallurgy. Now, some of you may have seen a bit of my work. So the first few slides are going to be a bit of what you've seen, or some of you at least. But then later on, try to incorporate a few extra things what I've, I suppose, towards the back end of my thesis, what I've developed, and how I could apply the actual new flotation test. So this is what the presentation is going to be about. So when I came here, the aim was to provide flotation-based recovery information, which will be used to populate deposit block models with recovery predictions that incorporate inherent geological variability. So what do they currently do? Well, how do they currently incorporate suppose the recovery variability is they conduct 5-liter batch flotation tests. With the 5-liter test, there's a lot of mass that is required. It's very time consuming because the grind calibration is required. It's very expensive for a geometallurgical application. And yeah, I've been, as Ben just said, I've been working in JK Tech. I think I've done about 100 flotation tests in the past 2 months. So speaking about flotation makes me really happy. So yeah, after I developed, so yeah, this was a disadvantage of the current test, was to, because of all these, because of the mass and it's time consuming. But now with Geomet, they wanted something that is cheap and fast. So I came up with a test, a small scale test, which required less mass and was not as time consuming. So the amount of mass that I came up with was 250 grams for my test, and it took about approximately 20 minutes to conduct the test. So that's a massive difference from what is currently carried out. There's a bit of validation that needs to be, that is required for it to be, I suppose, officially the official test. But yeah, I suppose I'm going to get a PhD from it, so I would say it's pretty official. So how the tests work is the following. So you have ore, you crush it to 100% passing 3.35 millimeters. You split the sample in 250 grams. You crush it to 100% passing 212 microns. You conduct your 1.5 liter flow test and you obtain your recovery number, and from that a mass and metal number. Now, as you can see from the top right hand corner, I have coarse assay rejects. Now that is very important because each drill core has coarse assay rejects. From the coarse assay reject, you can actually conduct a full flotation test from that, which is, they currently don't do anything. The coarse assay rejects currently just sit in storage, and so you can actually go back and actually look at past data and actually conduct many more small flotation tests because you only require 250 grams. Yeah. So this is obtaining a recovery number through conducting the actual test. One of the other things that came out of my work was determining a recovery number through just a mass recovery number. So determining a metal recovery from just a mass recovery number. So that is not even conducting a few tests, and then you can suppose extrapolate to actually determine metal recovery by just purely mass recovery without even having to send stuff off for assay. You can actually determine a metal recovery based on mass recovery. Again, that was towards the back end of my thesis, and I think I gave a presentation about a few months back on that. If you want to know more information about that, yeah, feel free to come talk to me. So this was the actual test procedure. Then I applied it to two deposits. First was on a set of drill core samples from Cadia East, and secondly from blast hole samples from Telfer. I used 12 drill core samples from porphyry, 12 drill core samples, and I conducted a 5-liter test using the conventional method, i.e. doing a grind calibration curve and then running the test, and then the 1.5-liter test, which is the test which I developed, using a planetary mill, which is the sample preparation method, and then conducting the flotation test. Yeah, so we did 2 repeats for each method, and the results show for the 12 different samples comparing the 5-liter cell recovery and the 1.5-liter cell recovery. The 1.5-liter cell recovery is able to pick up the variability that the 5-liter cell recovery was demonstrating. So that suggests that for geometallurgy, it is more important. Are you able to pick up variability with this new flotation test? We've answered that question with I suppose with these samples on this ore, and the answer was yes. As I said, we did on blast hole samples also. 8 samples were run. Again, 5-liter and 1.5-liter batch test. The method involved for the 5-liter test was the same conventional method, and the 1.5-liter test was the new test method. Again, you can see that the 1.5-liter test, which is the bold line, is able to pick up the variability that the 5-liter test demonstrated. So this was for a blast hole sample. So now we've demonstrated this on drill core samples and on blast hole samples, which the blast hole samples mainly use, I suppose you could control short-term for a short-term application, whereas the drill core could be more applied on a long-term application. Again, how can we apply this test? Long-term application and short-term. So with the information you obtain from characterizing, the characterizing information that you obtain, the characterizing information is the following. Lithology information, head assay information, together with the recovery information. It undergoes class-based analysis. So class-based analysis is basically trying to interrelate variables, to try and obtain variables which are interrelated through a process known as PCA analysis. Through the class-based analysis, you develop class-based models, which will then identify your processing domains and your resource block model, which is the ultimate aim of this. So, yeah, a case study conducted by Lou Keeney. I'm just trying to demonstrate what. First of all, I'm going to try and explain how class-based analysis is used, and then I'll demonstrate how my test can fit into this class-based analysis. So I'm going to use a case study to demonstrate this. So a case study conducted by Lou Keeney at Cadia East on an ore. They first use a universal model to, I suppose, to describe the ore. And there was an error on the copper recovery of plus or minus 17.2%. So the universal model is just based on assay values. They then thought to themselves, how can they improve this model? So they used the multivariate model. So the multivariate model is using head assay values and rock parameters, because at Cadia East they realized different mineralization styles control recovery. The model improved, so the error was reduced to between 5 and 12%. Now the method of class-based analysis so uses recovery numbers, rock parameters, and head assay. So the universal model was just head assay, the multivariate model was head assay plus rock parameters, and the class-based model was rock parameters, head assay, and recovery numbers. And you can see how the residual error on the copper recovery is reduced to between 4 to 8%. So this is just demonstrating why you should not just use lithology and alteration to describe your domains. So you can see from the domains developed, you can see alteration and lithology, there's no linkage, there's no direct linkage between alteration and lithology and the recovery domains that were determined. So you need more information than just lithology and alteration. So where does this new flotation test fit in? It fits into the characterization phase. yes, the model was improved, improved when you use recovery numbers, but in this case, yeah, in this case they use 80 to 120 flotation tests. So they use 80 to 120 flotation tests plus the rock parameters and the head assay, and yeah, the error was 4 to 8%. However, by having a new flotation test, you're able to have more recovery numbers. So having fewer recovery numbers, having more recovery numbers is better because you can have clearly defined boundaries, and more clearly defined boundaries. So for example, if you look at the domains that were developed, each domain had an average recovery of 87% with standard deviation of plus or minus 7%. But you can see this is using 80 to 120 flotation tests. But you can see the domains, I suppose you can call domain 1 domain 2 because the deviations overlap each other. And you can see domain 2 could be easily domain 3 because of the deviation overlapping each other. So the aim is, I suppose, to try and reduce the standard deviation. How can we do this? Or we can use the new flotation test. So with 80 to 120 standard flotation tests, that's about 400 to 600 kilograms of sample mass, assuming you use 4 to 5 kilograms per test. If you take 250 grams for the new flotation test, that's approximately 2,400 tests. So instead of 120 standard flotation tests, you can now have 2,400 flotation tests, and hopefully obtain a more accurate understanding of the domains, and thus have a reduced standard deviation on the recovery. What other benefits could the new flotation test have? Well, economically. So this was a study conducted by Alan Bai in 2011. The circled areas were the regions where they originally wanted to mine. However, with extra metallurgical information, these areas proved to be uneconomic. So if you look at it graphically, so there's the red line is I suppose the Geomet model, and the blue line is the base case model. As you can see, they're the graphs don't really correlate. They correlate, but there's regions whereby the GEM model suggests you're going to make more money, or the model suggests you're going to make less money. Well, from all of this, there was $50 million difference between the base case model, which came up by site, and the GEM model using processing tests, rock parameters, head assay values, using all the geometallurgical information. There was a $50 million difference. So more importantly, we're able to identify risks, and such that you're able to optimize, I suppose, the mine schedule. You can alert operators, and people can come up with a different mine schedule. Speaking of scheduling, how else can this contribute? Well, by conducting, the block model contributes to the scheduling of a mine, so you can have a better understanding of where to send feed. So if you conduct a few flotation tests, you can understand whether you send it to, like, for example, train 1 or train 2. A high charcoal pyrite zone is required to send to a bulk flotation circuit. If you have a high pyrite zone, you need to send it to a sequential flotation circuit. But the only way you can find out if you carry out a quick flotation test, you understand the ore that needs to be sent to the mill or sent for processing, and then you can suppose direct it towards the bulk circuit or the sequential circuit. What are some of the geometallurgical advantages? So this, I spoke about the long term. Now the short term advantages. So I've come up with the short term advantages are mainly using the blast hole data information. So this is just a processing scenario that I've just set up. The costs itself don't take too much note of the actual numbers. I mean, I try to make it as accurate as possible. So in terms of mining, milling, transport, royalties, depreciation. Yeah, so I just set up a processing scenario, but the aim is just to demonstrate what effect it has. Knowledge beforehand. How much does that play a role if you have the knowledge beforehand compared to, I suppose, when you don't know it? So I took an example on a single bench, right? This bench may have an average recovery of 40%. So using just one recovery standard flotation test, they assumed a 40% recovery for this whole bench, or the average for recovery for this whole bench is 40%. The information is just based on head grade and geological data. So the cost, as I said, is based on this. The revenue is based on tons mined and recovery of metal and grade. And you can see you're losing about $100,000 from it. This is just based on information on grade and geological information. They assumed an average of 40% of this bench, and they're going to lose 100,000. However, when you actually conduct a test, so if you conduct a small-scale test on the bench, you can conduct maybe say 10 tests. You can actually realize, you can distinguish that the bench has different recovery zones, 40, 75, and 90, with an average of about 68%. The cost is that much, the revenue, and anyway, you're making a profit of $700,000. So before you actually had a clear understanding, you were losing $100,000. But when you actually have a better understanding, by actually having actual recovery information, you can have a profit at $700,000. So you wouldn't mine this initially because you thought you'd be losing money. However, in actual fact, you should be mining it because you'd be gaining $700,000. What are the other short-term advantages? Well, in cases, some sites have a threshold on, I suppose, the amount of arsenic, for example, or the amount of fluorine that they require in their concentrates. You can, again, carry out a quick test to understand if there's the amount of arsenic and whether it should be sent to for processing or not. And penalties for arsenic can range between $3 to $4 for 0.1% over the limit. So I mean, for a typical ore containing about 0.5% arsenic, that could be $9.90 per ton. And if you, I suppose, if you're producing X amount of tons, your price could, I suppose, it'll increase dramatically. Other short-term advantages, you could detect iron sulfides in copper concentrates, and in that you modify the circuit. By modifying the circuit, you could add a depressant or increase the EH value. Yeah, so these are some of the measures you could take, you could conduct before the ore is actually sent for processing, and you can avoid these problems. So this is in conclusion. We have a new test method that uses less mass and time. A new test method is effective in predicting final recovery. The sample-to-sample trends are similar for two methods, for the drill core and the blast hole samples. And there's a long and short-term geometallurgical application, which I've demonstrated some of the advantages, some of the ways you can use it in long-term and short-term. Now this is something different that I read about this article about this week sometime, while I was extremely busy at Summer Park. I thought it was very interesting. But I'm speaking about geometallurgy, and within geometallurgy, it's very crucial. I mean, I'm sure you've heard the message that for geometallurgy to work, for example, I'm just going to relate it to geometallurgy. You need the geologists, the metallurgists, the engineers, you need everybody to actually communicate and get together. I mean, they may have the best intentions in mind, but if they're not communicating effectively to the stakeholders, they're not going to get anywhere. So I thought that this is a very important topic in terms of how the importance of dealing with people, and to the fact there's nothing soft about dealing with people. What is soft? What is a soft skill? So soft skills are personal attributes that describe an individual's ability to interact with others. The soft skills enhance career prospects and job performance. It is also known as people skills. It is known that the hard skills will get you a job, but the soft skills will actually ensure you keep the job, or actually you can progress in the actual, you can move up. The soft skills is what will get you move up in the company, I suppose. And soft skills are tied to personality rather than any training. I mean, they say soft skills is something which is in you. Maybe you're an optimistic person, or you have a sense of humor, or it's related to the person. And I don't know if there's any form of training that can actually train you to be a funny guy, or but no. So anyway, yeah, the importance of soft skills in the workplace. I don't think anybody has dwelled enough on it, on how important it is to actually the dealing with people. I mean, I met the manager of, well, he's my friend. He's one of the managers at Autotech, and he was just telling me that just a few days ago they retrenched a few people. And I asked him, so what are the reasons? Why would you retrench person A or person B? And he said, well, one of the guys, he was just not easy to deal with. And this is the reason why. He may be technically gifted, but he was just not easy to deal with. Nobody wants to work with the guy who's not easy to deal with. Either A, they'll stick you in the corner and just leave you to do what you do, or B, they'll get rid of you because nobody wants to. And it's not helping anybody. So anyway, I was just trying to, it just came to me like I think it would be something nice to share with everybody. So what are some of the importance of soft skills? I mean, they say, this is all stuff which I was reading. They say strategy is a doodle compared to getting people to enact it, right? It should not be nice to have, it should be core to how you run a company. Because when you come to work in the morning, everyone is different. They have different personal issues that they come up with. Either something happened at home, family problems, or they have anxiety, depression. But how you deal with it will make a massive difference to how the day is going to go. And that's going to contribute towards how the job is going to, how you're going to perform on the job, which I suppose contributes towards success or not. So how you deal with people as a leader or as an employee or as an employer, how you deal with people will make a massive difference. And how you deal with their problems also will make it, is an important aspect. I mean, you may, for example, you have the best flotation reagent you come up with. It's going to improve your recovery by 20 or 30%. But if you don't convince the right people that this is really good for you, if you don't have the art of convincing them, nobody's going to take it. So, point being, it is really important to actually be able to communicate information. And I don't know if you've noticed in a room full of people, in a boardroom, for example, most of the time, the person who's running the project is not the most technically gifted. The guy who's running the project is the guy who's able to bring everybody together. And the technically gifted person will be there, but the guy who's actually running the project is the guy who's able to bring people together. And that's contributes towards the success of the project. I came up with I read a few statistics on the global components of Australia. Australians generally have a poor reputation, leadership-wise. Just generally. The employees are more disengaged on average, like 28% being disengaged, and a further 40% are unsupported or detached. So unsupported means they're traditionally engaged, lack energy or sustainable engagement, or detached means they feel supported but they lack traditional engagement, so it's one or the other. 44% have confidence in their leaders compared to 52% globally. I suppose that's a stat which could improve. However, immediate managers fare just a bit better. It says 57% of confidence in their immediate managers compared to 61% globally. Now, why is Australia marked down? I suppose we can have a bit of a discussion on that. That's why intentionally I left my presentation short. Is it potentially the geographical location such that there's less competition for leadership? Nobody wants to act. There's less fight to become a leader, so the leadership programs here are not that, I suppose, intense. Maybe lack of importance of EQ in the workplace. People cannot feel, they don't feel the need, or they don't want to actually approach their boss with any problem, or there could be several other reasons. This is why I left this open. And yeah, in conclusion with regard to this, it says, I read this, is HR and internal communications should be a leader's best friend that can make or break your success. They say it is a soft skill. It is actually quite a hard skill to master. So my question to you is the following. In a research sort of environment, do you think that researchers themselves have the soft skills that are required? Are there any, I suppose, not courses, but anything that can be done to improve this? How can we bring ourselves parallel to sort of mining companies in terms, because that will, at the end of the day, get researchers business and and vice versa. What is your take on soft skill? Are we on par? Do you think it should be second rated, or should it be really the core of a company? So yeah, I just thought it was really important. So other than having questions on my geometallurgical work, please feel free to ask me anything about soft skills or have a discussion amongst each other. I can have a glass of water, so thank you.
I think you actually got the right thing at the right environment. I think it's really, really good thing. What really I would like to really know is your approach or the technique that you have developed based on the work that you have done. You showed that it's got a significant economic benefit to the mining companies with the limited work or the test work that you have done. The question we all will face, and that's one of the questions you're asking us, is if it is that good, what is actually making us not implementing it in a routine manner? Where are we lacking? If your test is that good, I would have, if I'm making $15 million per annum, I would like to do it since yesterday. Why we are not able to do it? What is that actually lacking, or are we actually selling some of these things too quickly?
In my opinion, I think there's a lack of support. In my instance, for example, I would love to see, I suppose, the idea, or my idea, gone out there to be saving companies $50 million. But I believe there has to be, it's hard for you just as a recent graduate or a student to drive it yourself. I mean, you need support from someone who is of more authority or who has a few more interaction with the industry or direct interaction with the industry to say that I know one of my students or a student, Jake, who will develop this year, would you be interested? I think there's this lack of support, or I suppose not the researchers or whoever not selling the idea of what in my case, what I have developed. They're not selling the idea as best as they can. It's more as well, yeah, not selling the idea as best as they can. Maybe that could potentially change, and you could also ask myself, I'll put up a proposal. I'm going to visit BHP this week. Would you like to A, come along, or B, I can take a proposal and give it to one of not the person you actually told me to, but they will have someone they can talk to or suggest, maybe you want to ask this person. And even if it's not a project which is going to be run within the next 6 months, they can tell you, hey, come back in a year, because I think this is very interesting, or we're running our Geomet program within 12 months. But at least they have me in their mind. So, but that is not happening at all. They don't even have us in their mind, or they don't even have the idea that, hey, there's a small scale test out there which has the ability to save us X amount of dollars a year. That's just my opinion. People can have, are open to it or have a suggestion or comment.
I just wanted to ask, how many ore types have you actually done your test on and proved that it's significant or it's quite close to the original 5 meter?
2 ore types, so one is from the KDEs and one is from Telfa.
Oh, so you just did it on those two?
Yeah, yeah.
So that might be the problem. Maybe people want a more proven test and they're very reluctant to change from traditional.
Yeah, true. I do believe that the test requires a bit more validation, or a lot more validation, made on different sites. But again, you need that support to say, oh, you know, hey, someone needs to say, hey, there's a site in Chile that wants to try to set, you can A, validate it, and together validate it, you can do some work for us. The results that develop from that, we can use it A, this way or the other. Yeah.
Just a comment on your soft skills section. I guess it's really important in people's future careers. And one of the things that's also very important is to be able to network with other people, because individuals don't have all the answers. They need to be able to talk with other people, speak to the people they know have the answers. And surveys have been done within the industry looking at people who are considered stars in their professions, high-performing people. And what's been found is they tend to be the people who have the best networks. So they know people they can contact and find out the answer quickly rather than trying to do it themselves. I think that's one of the risks we run into with the PhD training, and that is people tend to try to do everything themselves because they have to make an original contribution. But what companies need is people who know someone who can tell them how to do it quickly. So I guess for people doing PhDs, I would encourage you to find people who know how to do stuff rather than trying to reinvent it yourself. So talk to people who've got the experience and build on that to make a contribution rather than trying to reinvent the wheel yourself. As Newton once said, if he's been able to see farther than other people, it's because he was standing on the shoulders of giants. So when you're doing PhD work, bear that in mind as well.
Just alluding to your point there, you said encourage students to ask people. Do you believe that with many foreign students at JK, just talking about JK, there's English is a second language. How much does that contribute towards people being shy, or I don't want to even ask him because he might say this or that. Just because English is not. How much does that play a role, and how can we overcome that?
I don't know how much it plays a role because I'm not a student who speaks English as a second language, so I guess you'd have to ask
some of the students who aren't.
But it,
amazing contribution, just amazing.
Well, I think, I can answer that. Well, English is my second language. I think is even more important than that is your personality. I mean, regardless of how you speak English, you have the right, or you have the personality to ask to someone. I think it's more relevant that having English as a second language. So, in that sense, I agree with you in terms of the soft skills are something that I believe that you're born with those set of skills. I mean, it's quite difficult to train one guy who doesn't have the right set of soft skills, and become or transform this guy in a leader. You know?
I'd just like to comment that the problem that you're talking about, getting methods, techniques, whatever you want to call it, transferred across and being used in industry, the difficulty with doing that is a perennial problem. It was a problem when I was a student, and I think it will remain a problem. It might be even somewhat more difficult now because companies are more risk averse, but they are also supposed to be trying to find methods that do make them more efficient. And don't think that other people haven't faced this problem. Every student, I think, who has produced some useful outcome stands back and wonders, why don't people make more use of this? And sometimes you have to do it yourself, even though that's not the advised method, to start making inroads in that transfer from small scale to the real world.
So, one of the big problems is banks looking for a bankable study. If a company puts in a study, they look, it's used a non-standard flotation test, that's not going to be accepted. Maybe there's a possibility of using some standard and some pure improved. So if it's going to banks, they get very suspicious of non-standard.
That's definitely also an issue.
Well, this is gonna be the last time that I can ask you some technical questions. Rather than the rock type that you tested, because what Geomet is about is trying to improve the rock type definition. I would like to know the scale. What is the length of the triple that you tested? Is a bench height meter? Is a SA meter? Because this pretty much will tell you the order of magnitude in terms of the variability that you're going to have in the bench. Right? So if you take, for instance, 15 meters interval, which is a bench high, then you can say, well, within my block model, this block model will have this variability. Yeah. Whereas you can say if you do the test within 1 meter interval, you can say, well, this is the variability that you're going to have intra-block model. So, which order of magnitude?
So my test was converted in meter intervals.
Meter.
Yes.
SA interval.
Yeah.
Okay.
Yeah.
And did you see any kind of spatial coherence? I mean, did you do a test and a three-core tone profile, or you took just random three-core samples and you analyze the variability then?
No, the drill core I took were from a downhole profile, and we're able to distinguish different zones from downhole, high performance or high and low performance. So you could establish a profile downhole.
But this high and low performance was, which sort of statistical tool did you use to come up with this analysis? Did you use a diagram or did you use something else?
Trend analysis.
Trend analysis.
Mitesh, nice to see you again. Comment and question. Because I'm not comfortable with the number you always quote in the flotation. 5 kilo test, standard flotation for each test.
Yeah.
And for your test, you need 250.
Yeah.
You need only 2 kilo. The grinding is just a few kilograms at the beginning. Divided to if you do 100 tests, you don't need 105 kilo. Because you do the grinding at the beginning and then you go into 2 kilos. But yours is 250, that's the same thing. You need the grinding. This is my comment. My question. I assume you do your small grinding in dry state.
Yeah.
And the standard in wet.
Yeah.
Okay, it's been shown that flotation response is never the same when you do wet grinding and dry grinding. That's something you should also keep in mind, that the flotation response might be different because of the grinding, dry and wet. That's something you should be careful about.
Yeah, no, but in my case, thank you for your comment. In my case, I was looking at the final recovery numbers, and in this case, it didn't show that difference. But yeah, it's something that you've got to be aware of, that the wet and the dry could potentially make a difference. So.
What I think is Mitesh is trying to do is trying to come up with proxies, no real flotation numbers. Because at the end of the day, what you want to do is identify zones with high and low recoveries, and then you have to do a proper, well-known flotation test to confirm whether this domain that is showing a higher recovery is exactly the difference in order of magnitude in terms of the high recovery numbers that you have in one domain and the low recovery numbers that you have in another domain. So at the end of the day, you will have to do a proper, well-known flotation test to confirm that this zone is higher because of recovery than the other zone. So this is one of the things that is sort of misleading. What you want to do is a proxy for flotation, not a real number. So in the short-term planning, what you have to do is identify zones, but at the end of the day, you will have to do a flotation test to confirm that this zone is better than the other one.
Yeah. I suppose it's like if you do several CIs, we need to confirm something. Students, no questions?
Mitesh, coming back to marketing of your research, rather than you, because you have done with the two numerous sites,
Yes.
Acadia and Togo. Probably a way to do it is go and talk to new press and then get this idea to them and use them actually to market the project. The way to do it is probably to write one or two industry-based papers, okay, present that in the industry conference, and then use, or probably something like that. And then the outcome from those conferences or the publication, you use those to convince the other sides or to convince the other manufacturers. Probably that might be the goal. Okay, that will, you'll have a much stronger base, okay, because you have the support of big mining companies that validate your results.
I suppose I may have been misinterpreted the message, but not necessarily trying to market my idea. My aim of the second part of my presentation was merely to just, I suppose, share with the audience the importance of soft skills in English, not generally promoting my idea. It was just how do you feel that as researchers we're up to date with I suppose we're on the ball with regards to soft skills, or we just all technically gifted people, and that's where it just ends.
No, soft skills is very important. I totally agree with you, because I guess being in the private sector, it's not only doing the technical stuff, you must be able to sell projects. Okay, and definitely for that you need soft skills. And as this one can say, the network is very important.
My question is about, you have seen a slide in which there was one bench which is showing 40%, and then after that you have 3 different grades in that. So for that you will be having 3 different core samples. It means number of samples are increased during sample collection, which a geologist would design. And the second thing is, when you have different grades at different points, your whole mine plan is changed. So the whole story, starting from the capex and opex, would change to decide the economic feasibility. I want to know, and I'm worried about, what is the reaction of geologists and mining engineers on this?
Sorry, what is that?
What is the reaction of geologists on this sample collection change, and since the number of samples are increased, and the mining engineers on the change of mine plan and how they mine is changed? Because that have to be that much accurate, so that they can go for mine plan accordingly.
Well,
Mostly you are feeding more information about flotation and maybe other factors, so the mine plan would change, I think.
well, with the one sample, you require 4 kilograms of mass. But if you're going to take 3 samples, you're only going to require 750 grams. I'm pretty sure they'd be more than happy to have an understanding of recovery on different parts of the bench, rather than just conducting the one test with 4 kilograms, conducting 3 tests with 750 grams.
But it's not about the weight. Anyway, you have to drill core inside the bench. You have to go 5 meters below the ground. So anyway, you have to go below the ground, and there are regulations for the size of drill core for particular samples. So whatever be the amount of sample you need, you have to go and drill core to
But
that.
blast hole samples are always readily available.
Yeah, blast hole, yes, you can take it. But about the drill core samples, because
there was related to blast holes. That example you just alluded to, yeah.
okay, but if we take this thing on green on starting projects, when there is no some on greenfield projects actually, so you can't have blast holes that initial stage.
Yeah. But
So
you have
what would be the
assay
strategy at that time, at that point?
You have, of course, assay rejects. Yeah. So you're going to have your assays anyway. So you can just take an assay reject to conduct a flotation test. Because the assay rejects, it's sample mass which is just stored. So you can use that. The mass is sufficient enough to carry out a small scale test.
Just comment on this soft skill.
Yeah.
It's really like from physical point of view, it's really like the potential. If it has a very high potential, you will release this potential or to realize, to implement the potential. So I think that's really true for students to build the inner capability. Because like a communication skill or the other tools with people networking. It's all like in the process of building capability. For us, although we are staff, we are still in the process. We also building this. This really is like to enhance potential, to build potential. Any more questions from Mitesh?